We are excited to present our analysis of a powerlifting dataset, a snapshot of the powerlifting database sourced from Kaggle. This dataset provides a comprehensive record of powerlifting competitions, including competitor performances in the squat, bench press, and deadlift, the three core lifts in powerlifting. Our team Michael, Feza, Alia, Robert, and Shubhangi conducted 5 key analyses to explore various aspects of powerlifting performance. With the widespread misinformation on the social media about strength standards, our goal was to use real world data to gain objective insights into powerlifting performances across different age group, countries, weight class, and experience levels. Our findings not only help us understand how our own strength compares, but also have real world applications, whether for aspiring athletes, coaches, or those interested in the data analytics for health and fitness. Our table of content includes the introduction, data set, the analysis we did, and the conclusion. So, analysis 1 is based on age and strength analysis in powerlifting. The key variables used in the analysis were age, best lifts in bench press, deadlift, squat, and total strength. So the formula for total strength is the cumulative of best bench press, best deadlift, and best squat. The filter applied is we removed age less than 15 years. The method of analysis is following. So we can see histogram of athletes' ages to understand the age distribution. Next, we can see the box plot of strength by age groups to identify trends and variation in the strength. Here we can see the breakdown of strength components by age and compare how bench press, squat, and deadlift changes with age. So the insights from the data is the peak strength is mostly in the late 20s to early 30s. Some lifters maintain strength into their 40s. Deadlift and squat decline faster with age than the bench press. What can we do with this intelligence? We can adjust workouts based on the age. We can improve age-based categories competition, and we can modify intensity of the for the older lifters. Analysis 2 is based on the age class analysis by gender to identify peak strength periods. The data used in the analysis includes the age classes, sex category, and average IPF points. The IPF point is the scoring metric used in strength sports like powerlifting to standardize performance across different body weights. The method of analysis include we again removed age less than 15 years and we averaged the IPF point for males and females in each category. So if we look at the bar chart, the x-axis represent the age classes and gender, and the y-axis represents the average IPF points. The color coding is to distinguish between male and female. Male is in orange and female is in blue. And displayed numeric values on the bar is to highlight the key stats. The insights from the analysis are both male and female peak in strength between the age of 24 to 39 age range. The highest average IPF point occurring in the 35 to 39 age group. After the peak, there is a gradual decline in the strength across both the genders, and the drop is more pronounced in the older age group, 50 plus years, where IPF point significantly decreases. Also, across all age group, male consistently score slightly higher than female. However, the performance gap between gender is smaller in the older age group, suggesting that male strength declines more sharply over time compared to the female strength. What can we do with this intelligence? We can design age specific strength programs focusing on peak strength development and gradual maintenance for older athletes. We can adjust competitive expectations based on the peak performance trends, helping lifters plan their career progression and peak at the right time. Uh, we can tailor coach methods to address different strength decline rates in men and women, ensuring longevity in the powerlifting careers. Our analysis 3 is based on the comparison of average IPF point by country to identify powerlifting dominance. The data used in the analysis included the um, IPF point, and it provided a country-wise breakdown of powerlifting performance, helping identify dominant region. The method of analysis is the geographical choropleth map uh, to visualize the average IPF points per country. The darker shade represents higher average IPF scores, indicating countries with strong powerlifting performances. The insights from the analysis were China and Vietnam show the highest average IPF points, suggesting these countries dominate in powerlifting. The European countries have also have strong performances, with some African nations showing emerging strength trends. There is significant variation across continents, potentially influenced by training culture, infrastructure, and participation level. What can we do with this intelligence? This intelligence can help athletes and coaches benchmark their performances against global standards. Federation can identify powerlifting hotspots and allocate resources to the underrepresented regions. Researchers and analysts can further explore factors contributing to powerlifting dominance, such as training method, genetics, or competitive environment.
Alright, I'm Michael, and I'm going to be picking up at analysis 5, which is powerlifting strength correlation matrix. And the data used in this analysis is, of course, the data set from Open Powerlifting. The key variables are body weight, and then best lifts, and then total kilograms, which is the summation of the best lifts in bench, deadlift, and squat all added together. So these are the results from my correlation matrix. And so the correlation matrix showed strong positive correlations. As you can see, bench press and squat 91, bench press and deadlift 88, squat and deadlift 92, and then all lifts with total weight 96, and then body weight and total weight is lower at 66. So some insight from this analysis is there are high correlation among lifts, over 85%. It shows that athletes who excel in one lift tend to be stronger in others, indicating strong relationships between different lifts. The relationship between body weight and total kilogram is R equals 0.66. And the correlation between body weight and total strength is noticeably lower than the correlations among individual lifts. So lifts are a stronger predictor than body weight. So while heavier athletes generally tend to lift more, the relationship is not as direct as between individual lifts and total strength. So there is sufficient evidence without further modeling. So since the correlations are already very high, additional predictive modeling is unnecessary to establish this relationship. What can we do with this intelligence? A regression model will add limited insight since lift correlations are already high. A simple regression model would mostly confirm these existing relationships. Predictive models for individualized estimates A model could be useful for estimating one lift based on another, such as predicting bench press performance from squat strength. Outlier detection is also something we can learn from this. A predictive model can help identify athletes who deviate from expected strength trends, highlighting anomalies, and then also formalizing relationships while not providing new insights, a model can still be valuable for making structured, data-driven predictions. Getting on to analysis 5, which is body weight and lifting capacity. The data used in this analysis, obviously again, the open powerlifting data set, body weight and best lifts, but however there was a filter applied. Age that is less than 15 years old is removed. So our method of analysis is a histogram of athletes' body weight to understand weight distribution, a scatter plot of lifting capacity by body weight to identify patterns and trends in each class, and a box plot of lifting classes by weight to compare how bench, squat, and deadlift change with body weight to identify some trends and variations. So this is a weight distribution in powerlifting. You could see the highest number of participants around 80 kilograms. This is a scatter plot of lifting capacity by body weight bench. Very interesting. And here is a scatter plot of lifting capacity by body weight and deadlift. Also very interesting. And then the last scatter plot is of lifting capacity by body weight squat. Very interesting as well. And then we go lifting classes by body weight. So the insight from this analysis is from the distribution of body weight, right skewed with majority of power lifters in lighter categories. The highest concentration, as you could tell, was in the 80 to 90 kilogram range. Best lift performances increase with body weight in all classes. Heavier lifters tend to lift more weight in absolute terms. Moreover, the lifting capacity tends to increase more in squat than in deadlift and increase the slowest in bench. Average lifting capacity in all ages is 161.4 kilograms for bench and 224.5 kilograms for squat and deadlift. Then looking at the insight from the box plot and the variability within weight classes, variability in lifting capacities within each body weight class highlights that factors other than body weight, such as training, technique, and genetics, also play significant roles in determining lift performance. And what can we do with this intelligence? So understanding relative strength, while heavier lifters exhibit greater absolute strength, assessing relative strength, lifting capacity relative to body weight is crucial for comprehensive understanding. Calculating metrics like the Wilks coefficient can help normalize lifting performances across different body weights. The Wilks formula allows for the comparison of lifters by adjusting their total lifted weight based on body weight and gender, providing a standardized measure of strength. So we can also identify training opportunities. The observed variability between weight classes suggests that individualized training programs addressing specific weaknesses could enhance performance, and also informing competition strategies. Is understanding the distribution of lifting capacities across weight classes can aid in setting realistic goals and developing strategies for competition. And then analysis 6, does equipment, as in raw or strap, provide any benefit to the subjects of this data set? As in, does equipment or lack of have a negative or positive effect on amount lifted relative to body weight? The data used in this analysis is equipment, single ply, multi-layered, multi-ply, single ply, wraps, and raw, which is no equipment. The total kilogram, the minimum weight was 38.5 kilogram. The maximum was 1,000 387.5 kilogram, and the body weight with a minimum of 15.1 and a maximum of 258 kilogram. The method of analysis for this calculation, we looked at a strength ratio. Our objective is to find the average of each equipment using their pound for pound strength or total weight lifted divided by body weight. An expectation is you see expectation multiply single ply straps raw, as in we assume multiply is going to give the greatest strength benefit. And here are the results. As you can see from our insights, multiply outperforms all other groups, and raw had the lowest strength ratio. And there also is significant boost in single ply or reps in strength, but multiply seemed to give the greatest benefit to the athletes in the data set. So what can we do with this intelligence? It could lead to further research, for example, whether or not age, class, or gender affects strength ratio beyond just the equipment used. We can create estimations if lifters wish to transition from raw to any other three equipments. Get better advice coaching when dealing with athletes to determine their best case scenario based on their goals. And we can encourage companies to market the importance of lifting suits, knee wraps, or any equipment that that furthers the growth in strength and safety. Thank you.